Have you ever wanted to contribute to a project that supports multiple versions of Python, but aren't sure how you would easily test all the versions? Or did you ever want to contribute to a project that uses another Python version than you currently have installed? Are you curious about the latest and greatest versions of Python? Maybe you'd like to try out these new features, but you don't want to worry about messing up your development environment. Luckily, managing multiple versions of Python doesn't have to be a hassle when you use pyenv. Hi, my name is Johan Vergeer. And in this course, I would like to provide you with a great overview of how to maximize your time spent working on projects and minimize the time spent with headaches trying to use the right Python version. In this course, you will learn how to install multiple versions of Python on your machine, install the latest development version of Python, switch between the installed versions, use virtual environments with pyenv, and finally activate different Python versions and virtual environments automatically. The examples in this course are created on macOS. I've also used pyenv on Linux, which works just as great. pyenv isn't supported on Windows, but there is a similar project called pyenv Win. We won't go into pyenv Win in this course, but when you are on Windows, feel free to check this out. This is an advanced course which requires you to have knowledge about a couple of things. First, running shell commands like cat, ls, pwd, etc. This course assumes you know these commands. And installing dependencies using a command line interface. You might even have to do some debugging when you run into issues. Installing pyenv is pretty straightforward when you know your way around the command line, but some people run into issues every now and then. So, without further ado, let's get started in the next lesson with discussing why you would use pyenv and not just the Python version that comes installed on your system. So, why not just use System Python? System Python is the Python that comes installed on your operating system. If you're on a Mac or Linux, then by default, when you type Python in your terminal, you get a nice Python REPL which uses System Python. So why not use it? One way to look at it is that this Python really belongs to the operating system. After all, it came installed with the operating system. That's even reflected when you run the which command. Here, Python is available to all users as evidenced by its location user bin Python. Chances are this isn't the version of Python you want either. Python 2.7.16 is the system Python at this moment, which is no longer supported and should not be used for Python development as of January 1st, 2020. To install a package into your system Python, you have to run sudo pip install, which I won't run because I don't want to pollute my system, and even if you wanted to, macOS won't allow it. That's because you're installing the Python package globally, which is a real problem if another user comes along and wants to install a slightly different version of the package. Problems with multiple versions of the same package tend to creep up on you and bite you when you least expect it. One common way this problem presents itself is a popular and stable package suddenly misbehaving on your system. After hours of troubleshooting and Googling, you may find that you've installed the wrong version of a dependency, which is ruining your day. Even if your Python version is installed in user local bin python 3, you're still not safe. You will run into the same permission and flexibility problems described earlier. In addition, you don't really have much control over what version of Python comes installed on your OS. If you want to use the latest features of Python and you're on Ubuntu, for example, you might just be out of luck. The default versions might be too old, which means you'll just have to wait for a new version of your OS to come out. Finally, some operating systems actually use the system Python for operation. Take Yum, for example, which makes heavy use of Python to do its job. If you install a new version of Python and aren't careful to install it into your user space, you could seriously damage your ability to use your OS. Now that you've learned why you should not use system Python, let's move on to the next lesson where you're going to learn what a package manager can do for you. Now that you've decided not to use system Python, the next logical place to look is package managers. Programs such as apt, yum, brew, or port are typical next options. After all, this is how you install most packages to your system. Unfortunately, you'll find some of the same problems using a package manager. By default, package managers tend to install their packages into the global system space instead of the user space. Again, these system-level packages pollute your development environment and make it hard to share a workspace with others. Once again, you still don't have control over what version of Python you can install. It's true, some repositories give you a greater selection, but by default, you're looking at whatever version of Python your particular vendor is up to on any given day. Even if you do install Python from a package manager, consider what would happen if you're writing a package and want to support and test on Python 3.7 up to Python 3.9. What would happen on your system when you type Python 3? How would you switch quickly between the different versions? You can certainly do it, but it is tedious and prone to error. Never mind the fact that you want, for example, PyPy, Jython, or Miniconda. Then you're probably just out of luck with your package manager. With these constraints in mind, let's recap the criteria that would let you install and manage Python versions easily and flexibly. First, install Python in your user space, so you have full control and you will have no interference with other users. Second, install multiple versions of Python, which will allow you to test your project with multiple Python versions or work on multiple projects with different Python versions in your user space. Thirdly, specify the exact Python version you want for each specific project. And lastly, switch between the installed versions so you can try stuff out on multiple versions, run tests with multiple versions on a single project, or easily upgrade the Python version for a project. pyenv lets you do all of these things and more. Now that you know why pyenv would be useful, you'll learn how to install pyenv on your operating system in the next lesson. In this lesson, you're going to install pyenv, but before you can install pyenv itself, you're going to need some operating system specific dependencies. These dependencies are mostly development utilities written in C and are required because pyenv installs Python by building from source. In the real Python article that comes with this course, you will find how to install build dependencies for the most common operating systems. You'll find a link to this article in the description. So now you can pause this video, move to the article to install the build dependencies, and then come back here to install pyenv. Now that you've installed the build dependencies, you're ready to install pyenv itself. I recommend using the pyenv installer project, which is as simple as running the command displayed on screen in your terminal. If you're using another shell like zsh or fish, then replace bash with the name of your shell. I've already installed pyenv, so I don't have to run this command anymore. Before we continue, you should check your terminal configuration file, which is, depending on the shell you're using, .bashrc, .zshrc, or .profile. It should contain something like the following, which sets the path to pyenv and initializes pyenv when you start the terminal. I've noticed pyenv installer change the commands a bit over time, but it should be similar. When your terminal configuration file doesn't contain these commands, then you can copy them from this lesson's description. If you would like to know more about the pyenv installer project, you will find a link to the project's GitHub page in the description. A couple of plugins will be available to you after running pyenv installer. pyenv, which is the actual pyenv application. pyenv virtual env for creating and managing virtual environments with pyenv. You will learn more about this plugin later in this course. pyenv update, which is a plugin for updating pyenv itself and all pyenv plugins. pyenv doctor, a plugin to verify that pyenv and build dependencies are installed. And finally, pyenv which ext, a plugin to automatically look up system commands. Now that everything is set up, let's continue with installing a Python version using pyenv in the next lesson. Now that you've installed pyenv, installing a specific version of Python is the next step. You have many versions of Python to choose from, and to see all available Python versions, you can run the command pyenv install -- list. This is a very long list that might be tough to scroll through, so let's use the power of grep to see all available CPython versions for version 3.8 and 3.9. So let's type pyenv install -- list grep with a certain filter. And if you would like to know which versions of Jython can be installed by pyenv, you can figure that out just as easy by typing pyenv install -- list grep Jython. Once you've figured out which version you want, you can install it with a single command. pyenv install -v 3.9.1. The -v flag is added so pyenv will show what it is doing. Installing a version might take a while because pyenv is building from source, but I have fast forwarded so you don't have to wait until the installation is finished. For the rest of the course, the examples assume you've installed CPython version 3.9.1. But you're free to substitute these values for the Python versions you actually installed. Also note that the system Python version in the examples is 2.7.12. Let's have a look in the next lesson where pyenv actually installed Python 3.9.1.